For getting started with your Igneous Rocks lab. So the lab is two parts. The first part is focusing on rock identification, and then the second part is the really important part of the lab, which says, okay, so now you can identify these rocks, let's put them into context. So where do we expect to find these rocks in different tectonic settings? So it's the really important part of the lab. So even though it's just multiple choice, make sure that you're really trying to focus and use all the information available to you to try and figure out that part of the lab, because that's very important to get. As with the minerals lab, you are learning a skill set for how to go about identifying rocks. So I don't want you to think that you're memorizing the rocks. You're going to work on how do you determine different characteristics of an igneous rock. So from the lecture you learned that we classify igneous rocks based on both their texture and their composition. So here you can read more about that, and I recommend you read it before starting the lab. So this flow chart is going to be very helpful to you. And so we'll come back to that. Ultimately, the chart that you're filling in, you will try to identify the different rocks in your rock kit. And so you will be looking at the samples numbered 1 through 19, but keep in mind that there's not every number here, so you can see we jump from 7 up to 12. So there are actually only 12 rocks that you're identifying. So those are the rocks that you'll work to identify. And so to be clear, as with the minerals, the rest of the chart here, the color, the texture, the composition, the rock composition, and then intrusive or extrusive, those are things that you can fill in. You're not required to fill it in. But keep in mind that for the mineral and rock exam, you will be able to use this on the rock exam. So whatever you create here is helpful to you. For the exam, if you identify a rock correctly, so I'm talking about the rock exam in week 9. So the way that exam works is if you identify it correctly, then you get full credit. If you misidentify it, but you have a whole bunch of characteristics about it correct, then you'll get some partial credit. So it's up to you how you want to fill in these charts. It's really, when you look at a rock, if you have a certain thought about that rock, then write that down, because that, when you see it again, it's going to trigger something in your mind. So make notes of things that are important to you. So this is what you'll need to fill out. So the way you would go about doing this is you're going to use this flow chart. And so you will have pretty much all of the rocks that are listed here, except for you will not see peridotite. The way it works is you start here, and the first thing it asks you is if there are two distinctly different grain sizes. So an example of that is where you see, a rock where you might not be able to, you're not going to be able to see this very well, but where you have these large mineral grains and then otherwise the very fine grained. So maybe you can make that out. I'm looking at 12. Okay, so it's big minerals and then much finer stuff around it. So that is something that if we see that texture, we would call that porphyritic. So keep in mind in geology, when we talk about texture, we're not talking rough or smooth. We're talking about grain size. So, and the distribution of the grain size. So big grains, small grains, all the same size, or two sizes. So if you see two different sizes, then you're going to use the prefix porphyritic when you get to the point of naming your rock. So for an example, maybe you identify something as andesite, but initially you said, oh, but there are two grain sizes. So then that would be porphyritic andesite. And then you might see andesite again later. I'm not saying there's definitely porphyritic andesite, but that's an option. So first you decide, are there two grain sizes, are there not? If there are, then you're going to use the prefix porphyritic in the name. Either way you come out of this, and then you have to say, is it medium to coarse grain? So can you actually see the minerals in it? And this means all of the minerals are medium to coarse grain, not just some of them. So when you look at it, the whole thing is made up of minerals that you can easily see. So if you can see this, I'm looking at sample 6. That's one where I can see all of the minerals in it. Okay, so all of the grains, and that's where people kind of get hung up, because they'll say, well, I see some of them. If you see all of them, all are medium to coarse grained, then you're going to say yes, and you're going to move down towards the intrusive rocks. If only some are visible or none are visible, then you're going to say no, and you'll move towards the extrusive part of the diagram. So yes, you're moving down to here. No, you're moving over to here. If you say yes, then what you're doing is basically you're looking at the color of the rock and determining, based on the color, that's telling you what kind of rock you're looking at. Because that relates back to the composition. If you said no here and you move to extrusive, then it asks, are they fine grained? So are the, so you can see grains. It's not just all glass, or frothy glass. And so if it's fine grained, you're going to move up to this portion of the diagram. If it's not fine grained, so something that looks glassy would be something like this rock, where see how it has that shiny look? This is glassy looking. So this would not be fine grained. This would be a no because it's glassy. That's actually obsidian. So if you say fine grained, then you're moving up there and you're working through it. The rhyolite and tuff, I'll tell you right now, you'll have issues with it because the difference between those two rocks is that tuff is something that's so friable just means breakable. And you're not going, unfortunately, the tuffs that we often have in rock kits have to be a little bit resistant to erosion, otherwise they would break with the student. So the tuff is a little bit stronger than you might expect it to be. The way to look at it is if it's got flattened pieces of pumice in it, which right now you're like, I don't know what that is, but once you've identified pumice, then you'll know. But if it has flattened pieces of pumice, then you're looking at tuff. If you're seeing rock fragments, you're looking at tuff rather than rhyolite. So you'll move across this diagram. If at the end you're wound up here and it says black to red with vesicles. So vesicles are just holes in the rock. And so this is basically, the black to red means it can be anywhere between black and red. If there are holes in the rock, then you move up. If it's no holes in the rock, then you move over here. And then you have to decide if there's more holes than rock, it's called scoria. If it's rock with some holes, then it's vesicular basalt. So those two you'll have to differentiate. Okay? And so you will then fill in this chart here with all the things. The color, I worry less about that. That's kind of what might help you. Texture, is it fine grained or coarse grained? Pyroclastic means it's made up of rock fragments. Some of these terms you might find more in chapter 6 when we get to volcanoes, so you might want to look there a little bit. Vesicular is what we said about the holes. Glassy, that's the shiny appearance. Porphyritic, 2 distinct grain sizes. The mineral composition, and the rock composition, if we look at this diagram from your book, let me see if I can, what you'll see is, we classify igneous rocks based on their composition and their texture, so fine-grained, coarse-grained. And so here is showing you, if you classify something as, if you decide to call something a granite or a rhyolite, or any of these terms, this is the general composition. So you've got a fair amount of quartz, you have potassium feldspar, you have biotite, you have plagioclase feldspar, which is the sodium rich, but don't worry too much about that. And you might have some amphibole. Okay? So these felsic rocks do not have any pyroxene or olivine. And so you can see, as you move across this, if you're looking at an intermediate rock, you're going to have a lot of plagioclase feldspar, a lot of amphibole. You're probably going to have pyroxene, you might have biotite, you might have potassium feldspar, you might have quartz. They're not guaranteed. All right? And then in mafic, plagioclase feldspar, pyroxene, olivine, maybe some amphibole. Okay, so that's how you kind of read this diagram. And so this will take a little bit of time to think about. These rock type names tend to have, the reason these lines kind of extend across is because they have a range in compositions that go with those names. But for this class, we'll treat scoria as mafic, and tuff, these three, you can just lump them all into felsic. When you're talking about these minerals, these rocks, though, obsidian is actually made up of a volcano. It's glass, so it cooled so fast that there are no minerals. It's just all glass, so you could write that. For pumice, it's just what we call frothy volcanic glass, so there aren't actually minerals arranged in there. And the tuff tends to be some early formed minerals, but then ash and rock fragments. So that's what you want to kind of think about for when you're trying to talk about composition. That's what you would be talking about. All right, so that's where you're going to be dealing with here as you fill that out. And again, you don't have to fill everything out, but if you want to have that as a reference for when it comes time for the rock and mineral exam, you should do that. Okay, so you'll work through those. The second part of the lab is very important, and I really want to stress, so rather than answering it on here, you're going to submit it on D2L, and it's called a quiz, but it's just part of your lab. And so you can you can go through and answer things once, and then get feedback, and if you need to change some things, you can do it again for a second time. You don't have to do it 2 times, though. And so what this is the really important part, and I can't stress this enough. What you're starting with here, you're looking at tectonic settings. So you have these 5 different sites, and you have to determine what is actually going on regarding the plate boundary or other features. So it could be a hot spot or something. So, what is this feature, Site C? And it says a mid-ocean ridge that zigzags across the ocean floor. So you're going to want to come up here, and for C, you're looking at, well, what kind of plate boundary would that be? Okay, why does melting happen at that type of plate boundary? So you're trying to link that all together. And so that's what you want to be doing as you're looking at this diagram. And so I put this here so that you could answer on here if you wanted, but you do need to submit it on D2L, and I'll show you what that looks like. So what you'll also notice in these descriptions of the areas is that you have samples that relate to them, okay? So once you fill out this part here, this first chart on D2L, then you're going to start looking at some actual rocks, okay? And these rocks have descriptions with them as well, which might really help you trying to identify them. So what you're going to do is you want to make sure, and this is the part where I really don't want you to disconnect. So sample 1, when you're looking at sample 1 and trying to figure it out, you're thinking, okay, sample 1 occurs at site A, and you've already determined the tectonic setting. And so you can start to say, okay, that's what's this tectonic setting, this is why melting's happening, I can determine the composition of that. And so and you're looking at the rock, and then you're trying to figure out, okay, well, what's the grain size? What's the composition? And based on that composition, what would I name that rock? And then when you get to the cooling and solidification history, so keep in mind that a rock that cools outside of the earth, an extrusive rock, has a very fast cooling history, right? It just exposed and it cools off really fast. So fine-grained rocks, your extrusive rocks, are going to be fast cooling. When you've got really large crystals, those are rocks that formed at depth, and they had time to slowly cool, and the minerals were able to really grow and get big. So keep that in mind. So those would have slow cooling. Medium-sized grains are going to have moderate cooling. If you see something porphyritic, so 2 grain sizes, remember from the lecture, that's telling you there was time for things to cool slowly, and then all of a sudden it got erupted, and then it had to cool really fast. So porphyritic is your slow then fast. And then the last thing is pegmatites, and those form pegmatitic textures when the minerals are like gigantic. And the reason they're gigantic is because they cooled when there was enough water around. And so what the water does is it allows the minerals to kind of bring the elements that the mineral needs over to where it's growing. And so it can really grow, but then the water also prevents new minerals from growing. So it's basically like whoever got started really thrives, and it's really hard for new ones to start. So that's what you want to, if you're seeing pegmatitic, you want to be thinking slow cooling in the presence of water. So you will fill this out online, but make sure you're looking at the pictures, you're reading the descriptions, and then really important, tie it back to the tectonic setting to put the whole story together. Let me see if I can bring up the quiz for you guys. Actually, I should do it. Oh no, I gotta do it now. Alright. So let me just show you. So when you're in content, so week 5, you will see this investigation part that you're supposed to do. And so when you go into this, let me see if I can preview it on the fly. Okay. Okay, let's see. All right. So the quiz will start. You have unlimited time, so don't worry about time. I put the diagrams on here mainly just to remind you. So make sure you read, this is what your goals are with this section, okay? So here's the picture. And then this is basically just the chart broken down. So type of plate boundary or other feature for site A. So you would answer that. And then likely cause of melting for site A. So check all that you think applies to that situation. And then you just work through that. And so this first part is all that first table. And then when you see the picture again, now you're thinking about, okay, what can I say about sample 1? And I strongly recommend just maybe printing out the 2 color figures, having them next to you so you can look at them. Or if you have the book in loose leaf form, it's the chapter 5 investigation. And so you can look at those there as well. Or have it open and connect, whatever you need to do. But make sure you're trying to tie it all together. It might be the easiest thing to just have the whole investigation sheet out in front of you as you're working. But that's kind of, I don't want you to rush through this final part because it feels like just one last hurdle to get through. This is really the part where, because it's great if you can identify igneous rocks, but I want you to understand, okay, we have these igneous rocks, but when we see them, it tells us about the tectonic setting. It tells us, where magma was happening and why it was happening. So you want to be able to tie it all together. Okay. Let me know if you have any questions.